Hello, everybody, and welcome to another great day of chemistry. So, last time we were able to talk about various classifications of matter. However, it turns out that the classes, whether they're pure substances or mixtures, isn't the only thing that matters. One of the things that we often really care about are the actual physical measurable properties, whether they're physical properties or chemical properties. So, we're going to be going ahead and classifying um, what these properties are in order to assess the different types of matter. So, one of the most important properties that we can start with is whatever the phase or state of matter is. So, this is another way of talking about the arrangements of the atoms or molecules with respect to each other as a whole. So, if I have a whole bunch of atoms that are tightly packed, I get a solid. So, classic example of this is ice. As soon as I get more movement, I can go to a liquid phase. So think liquid water. And then as soon as we get a lot of movement in the system, we can go to the gas phase. And again, this all of these relates to different arrangements of the molecules with respect to each other. So solids, everything is very highly ordered and condensed. So these typically will be tightly packed. If I go to a liquid, then we're going to have a lot more movement. So this gives the flexibility because I start getting little pockets of space in between the individual molecules, allowing the molecules to slide past each other. And gases, well, this is pretty much a whole bunch of little kids high on sugar running around a room. Occasionally they hit each other. Most of the time they're just bouncing off the walls. So this is a good way to think about the major types of matter. And how we're going to examine matter will often depend on which phase we're looking at. So let's say I'm looking at a given phase, and then I'm going to want to subdivide the other types of properties I can look at. So the first good dividing line is physical properties versus chemical properties, which we talked about a little bit last time. When I'm talking about physical properties, these are properties that can be measured without changing the identity of the substance. So this can include things like mass, volume, density, color, smell. I don't actually have to change what the substance is to measure these properties. However, we also have things like phase changes. So boiling point is a classic physical property as well as melting point. So what this underlies a very important point. If I have a change in the state of matter, this is not the same as a chemical change because water is water no matter whether it's an ice or whether it's a solid or a liquid. The other major category is physical or is chemical properties. So this regards the ability or sometimes inability of a sample to undergo a chemical change. So one of the classic things, one of the classic descriptors is flammable. A substance is considered flammable if I can ignite it, essentially cause it to combust under exposure to a heat source. So this means that it can essentially undergo some form of combustion. It can react with oxygen um, and heat in order to decompose. So that is a classic good chemical property. Other ones include things like, well, rusting. So some metals can rust, some can't. This is a chemical property. It talks about what reactions a system can undergo. So one of the important things to note is that many of these physical and chemical properties are associated with certain types of physical or chemical changes, especially when we're talking about chemical properties. And what we're talking about when we're talking about physical chemical changes, so if I have a physical change, this is going to be a change in the physical appearance without changing the identity. So again, you can think about things like phase changes are a classic physical change. We can also talk about changes in mass, where I can grind up stone into gravel. This is a size reduction. I have a physical change, but it's still the same rock it started as. On the other hand, we have chemical changes. So this is actual changes in chemical composition. Again, classic examples being burning and rusting, which essentially are ways that a substance can react in the presence of oxygen. And there are such a diversity of various physical and chemical properties we can describe the system with. Temperature, mass, structure. So again, how the atoms are arranged with respect to each other. Color, taste. For example, acids are sour, bases are bitter. So if something tastes sour, it means it's acidic. And we'll talk a lot more about that later. But we also have things that regard to physical changes, such as boiling point, freezing points. And again, the list goes on for quite a while. However, when we're talking about these properties, we can subdivide how we talk about these properties into two key ways. And we're going to be using both quite a bit. The first is a qualitative description. So this is essentially a rough estimate of a property. So this can go anywhere from something like a lead weight is heavy, leaves are green, and sugar burns in the presence of oxygen. However, whenever we have a qualitative measurement, there's almost always a way I can put numbers to it. And because of the way chemistry works, we love putting numbers to things. I apologize in advance, but this turns qualitative measurements into quantitative measurements where I have an exact number. So for example, instead of saying a lead weight is heavy, I say a lead sample weighs 1.21 pounds, giving it exact weight. Leaves are green. Well, I can give the exact wavelength at which chlorophyll, the key component in leaves, absorbs light. I can also say that this can also apply to chemical properties, where I can tell you the exact amount of oxygen required to burn 1 gram of sugar. Giving this very important ratio gives a quantitative measure on chemical properties as well as physical properties. And this is actually a cool feature of chemistry, is being able to quantify the world around us. And again, this is one of the differences in between chemistry and a lot of other disciplines such as biology, which tends to emphasize qualitative properties. Instead, we're often emphasizing quantitative measurements. However, as you go on, you may find certain chemistry classes, such as organic chemistry, which tends to more emphasize qualitative properties. But again, it's going to be very important to remember that every measurement contains some error. And we'll be talking about this in a couple of lectures when we're talking about significant figures and how accurate each of these numbers are. There is no such thing as a perfectly accurate measurement. Now, one of the other ways we can talk about properties is a very useful feature, which often defines what measurement we use to describe a system. And that's based on size extensivity. So a size extensive property is one that depends on the amount of substance being analyzed. So if I want to know exactly how much of a sample I have, we're going to want to use a size extensive property. So you're familiar with most of these. They include things like mass, length, and volume, anything that tells me about the size of the system. However, we also have size intensive property. So these only depend upon the identity of the substance. They don't matter how much I have. So for example, it doesn't matter how much of a lead weight I have, it should all be at the same temperature. It should all have the same boiling point, and it should all be equally hard. It will also have, say, the same density. And density actually reveals a quite cool feature. And it's that the ratio of any two size extensive properties will be size intensive. And we'll make use of this periodically throughout the semester. If you can identify two size extensive properties, it will give you something that it will give you a new property that tells you about the substance itself and not just how the individual sample we're analyzing. So sometimes we do want size extensive properties. We want to know how much of a substance we have. But a lot of times, if I want to know about the molecule, the compound, the system, I often want a size intensive property. So it's good to know which ones can scale up and which ones can scale up and which ones don't. So next time we're going to be diving in a little bit more into our various units of measure, as we're going to be talking about, well, SI units, especially diving into mass, length, volume, and temperature. Until then, take care.